Hello everyone, myself Abhinav Kumar Bajpayee from Lovely Professional University, registration number 12407299.
Myself Kaveri, registration number 12406280.
Myself Sachin, registration number 12407482.
So, first giving the overview of the topic, it's adaptive resource allocation in multi-programming system. What is multi-programming? Multi-programming means multiple processes can run simultaneously, which will increase the CPU efficiency and memory efficiency also. So, but traditionally what happens, it uses static memory allocation, which has some drawbacks like CPU overload, memory exhaustion, bottlenecking, starvation, etc. So to come up with these, we have created an adaptive resource allocation system which will use dynamic memory allocation. So by using this, we can overcome these problems and it will increase the CPU efficiency and memory exhaustion. Thank you.
So talking about system architecture, this is a 3-tier feedback based system. First component is sensor. It is an monitoring agent built using PSUtil library. It acts as eyes. For our project, it interacts with OS kernel to extract real-time metrics like CPU load, RSS, and IO wait time. Second component is controller. It acts as brain. And for our project, this is a Python-based decision-making algorithm. Our project is using threshold-based algorithm. If it detects a process which is in its starvation or hogging state, then it calculates necessary adjustments to its priority level. Third component is kernel interface, the coding part in the kernel interface, which changes the system state. It executes system calls to modify the niceness value of a process. Now talking about working, when simulator starts, it initiates child processes using subprocess.popen. Then each process is assigned a unique process ID which is maintained in the process table. Our monitor runs a background thread sampling data every 500 millisecond to 1 second. The system evaluates set the sample data. If CPU usage is greater than 75%, then it is labeled as hog and its niceness is increased, which decreases its priority. This frees up resources for another process, ensuring high priority process have the headroom they need to function. Once this adjustment is made, the system continues to monitor to see if pressure has decreased. If the load returns to normal, the system can cool and return the process to its original priority.
So let me start with the key features of my system. First is dynamic scheduling. In this system, processes are not executed in a fixed order. The scheduling decision depends on the current system condition like CPU usage, process priority. This makes the system more flexible and efficient. Next is adaptive resource allocation. Here the system dynamically adjusts CPU and memory allocation based on workload. So when the system load is high, it optimizes resource usage, and when the load is low, it improves utilization. Another important feature is real-time monitoring. The system continuously monitors CPU usage and memory usage, and based on that, it takes an immediate decision. This helps in maintaining system stability. Then comes priority adjustment. The priority of process is not fixed, it changes dynamically depending on the factors like burst time and system load. This ensures that important or long waiting process gets CPU time. Also, we have a memory control mechanism If memory usage becomes high, the system removes or swaps out the low priority process to avoid overload and maintain performance.
So that was all of this project. So guys, thank you.